Hello everybody, this is Horned Frog Engineering. Today I want to demonstrate how to solve a system of equations that involves complex numbers. Usually you'll find these in circuit classes, AC circuits. We're going to denote J as an imaginary number. Usually you use letter I, but usually whenever you're taking circuits, it's going to be denoted J instead of I because I is usually current. So that's the reason why they usually denote it as J. So that's what we're going to use, but you could apply this for other classes too, in which you have to solve complex numbers, systems of equations with complex numbers. You can just replace this with I, but since this is an engineering class and we usually deal with circuit problems, we're going to denote this as J. So we have two equations over here, and normally in a TI-84 calculator like this, you're gonna create an augmented matrix 2 by 3. So let's do that, but what you're gonna find out is that you're not gonna be able to solve it with use the TI-84 to solve complex numbers. You're gonna have to convert it in some form. But let's create our 2 by 3 augmented matrix first, just to show you guys what it would look like if you could solve it as an augmented matrix in a TI-84 calculator. So your first equation, this is equation number 1 obviously, and then equation number 2. Your first equation is going to be 1 plus 2j on the first row, first column. And then second row is going to be 3j, and then for the third column, it's going to be 5j, still in the first row. And then you have your 3, and then your 4. This is the third column. So this represents x, this represents y, and this is going to be your constant, so to speak. X could be like current or voltage or something. I'm just going to denote it as x and y. What you're going to want to do is remember this formula. This formula is going to be, we're going to convert it into, so that you can solve it using your calculator. But you're going to want to remember this formula. And it will make more sense in a few moments. So R represents your real number, your real part of the complex number, and I represents the imaginary part. So you're going to want to remember this formula. So this is a 2 by 3 matrix, and then we're going to convert this into a 4 by 6 matrix. So you just double the row and you double the column. It's going to be a 4 by 6 matrix, and using this formula you're going to expand each of these terms. For example, for 1 plus 2j, the real part is 1, 1, 1, and then the imaginary part is 2, and then negative I is negative 2. And then for this part, there is no real part, so it's just 0, 0 for the real part, and then for the imaginary part is 3, negative 3. Now for this part right here, the real part is 1, 1, and then be careful with the negative 5. Positive I is going to be your negative 5, and then negative I is negative 5 times negative 5 is a positive 5, so just be careful with the negative part over here. Hopefully that makes sense. And then for this part in the bottom, we can see there's no imaginary part, so you're just going to be putting 3, 3, 0, 0. Again, R, R, I, negative I. This is going to be your real parts, and this is going to be your imaginary parts. For this one, there's only a real part. It's going to be 4, 4, and there's no imaginary part, so it's going to be 0, 0. And for this one, there's a real part and an imaginary part, so it's negative 6, negative 6. Your imaginary part is 1, and then be careful, it's going to be negative 1 up here. So now you're going to put that in your calculator as an augmented matrix. So here's what you're going to do is you take your calculator, go to second matrix. We have a 4 by 6 matrix. If it's not already a 4 by 6 matrix, make sure you edit it 4 by 6. And actually I have this already in my calculator. So you're gonna input every number on here. Just double checking, make sure everything is correct. One by one, of course, double checking every time. Once you have all your numbers down, go to second, quit, second matrix, math, then RREF, second matrix, and this is going to be your matrix A, in which you put all your numbers, and then enter. And then you're going to get an answer of this. This is going to be your real part right here. As you can see, your real part. If you keep going, it's going to be the same thing over here. Your real part is going to be 1.76 for, at least for x. It's going to be, your x is going to equal 1.765. And then your imaginary part, I would just focus on this one because this is, again, this is a negative I. So your straightforward answer is going to be minus 0.0588J. So that's our answer for X. And then for your Y, it's going to be, this is going to be your real part, these two, but you just take one of these numbers. It's going to be negative 2.824 minus, again, this is going to be your imaginary part right here. You can see it right here. I, but just take the answer that's over here, which is 0.294J. So that's our answer. But if you're taking a circuits class, your professor might want you to convert this to polar form. So we're going to do just that. We're going to convert this to polar form and give you the answer in polar form. So your X is going to equal, in polar form, is, you're just going to put the number down on your calculator. 1.765 minus 0.0588 I, because there's no J on the TI-84. They represent imaginary numbers as I, so just pretend J is equal to, it's the same thing as I. And then press enter. So what you're going to do, actually, before you press enter, you're going to want to have this in polar form. Go to mode. I already have it in polar form. And then you're going to see this part right here. Press enter. Second, quit. Press enter. And your polar form is 1.766. And then E, J, negative 1.908 degrees, or in shorthand form is 1.66, negative 1.908 degrees. That is your answer in polar notation or shorthand form. And then we're going to take this part right here, negative 2.824 minus 0.294 I. Press enter, and then your answer is going to be 2.839 EJ. And this is supposed to be positive, by the way. So that's a typo. So because this answer right here is a positive, so I apologize for that. And let me redo that. So it's positive 174.05 degrees. Or in shorthand notation, 2.839, 174.05 degrees. And this could be like your current or your voltage. I'm just going to represent that as X and Y. So this is how you solve systems of equations with complex numbers. If this was a, let's say this was like a 3x4 matrix, then you're just going to expand everything, and everything's going to be a 6x8 and so on. So you can, you can use this technique to solve systems of equations that involve complex numbers. And if you have like 3 or 4 or 5 equations, having the calculator, I believe, saves you a lot of time, especially in exams, so that you can manage your time well and get the answer using the calculator. And usually with AC circuits, you're gonna be able to use calculator like this for your class. So this is how you solve systems of equations with complex numbers, and I hope this was helpful. And the key is just to remember this formula. This is what you're going to use to expand each term. Real, real, diagonal, imaginary, imaginary, diagonal, but this one is going to be a flip negative sign. R, R, I, negative I. Alrighty, thank you for watching.